All right, so we have two final topics to talk about in Unit 2. We're going to look at composition of functions and then inverse of functions. So composition of functions is when I essentially do substitution, but instead of plugging in a number, I plug in an entire function. Pins ready. All right, so in the past, we have had the evaluate problems. Maybe I tell you that f of x is equal to 7x plus 3. And I ask you to find f of 2. So f of 2 says to take the x out and plug a 2 in. So I'm going to take this x out and put a 2 in. Now, order of operations, I need to multiply before I add. This is 14 plus 3. So f of 2 is 17. This is all we're doing. Well, let me translate. This is all we're doing, but instead of plugging in a number, I'm plugging in a different function. Okay, so there are two types of compositions depending on order. So this is f of g of x. So this is written f of g of x. So every time we open up the parenthesis, we get an of. This is written f of 2. So it's my function f using 2. This is going to be my function f using g to plug in. This one is written g of f of x. So I'm plugging into the g function my f function. So it's just substitution of something bigger. Instead of just a number, it's a different function. This is typically how we write compositions with the parentheses, but on your assignment today, you're going to see it written a different way, and it looks like fog, but it's not quite fog. So it is f with a circle. So it's not just a dot. It's not a like closed in. So it's a little circle, G, and then they typically put an X. So this is written with a little circle, which is said f composed of G and then of X. So if I was to do that with this here, I would find f composed of 2. Make that a little bit bigger with a circle. F composed of 2. So this is the same as this. So that little circle doesn't mean times. It means to compose the function plugging this value in. Use this function, compose it by plugging in the g function. Okay, so this one, starting with the g, this would be g composed of f of x. So the very first function letter that you see is the one that I start with. So this, like f of x, I start with my f function and I plug in 2. If I wanted to find from this function f of g of x, I would need to know what g of x is, but I'm going to take my f function, which is 7x plus 3, and then I'm going to plug in the other function here. So I take out the x and I put something in its place. What I plug in its place would be this g of x. So this would be my whole g of x function. All right, so let's do some examples. Okay, sorry about that. Paper is very sensitive on the computer. All right, so I have 3 different functions. No, I have 2 functions, but I have 3 different problems. All right, so f of x is 2x squared. I like to outline. And then my g of x is x squared minus 1. So f of g of x always starts with the outside function. So I'm going to start with my outside function, which is f. And f of x is 2x squared. So I'm going to write this function, but instead of writing the letter x, I'm going to put a parenthesis for my placeholder. So 2x squared. Right, so if I wanted to find f of 2, then I would plug in a 2 into this place where the x was. But I'm not finding f of 2. I'm finding f of g of x. So I'm going to take in this whole space the entire g of x function, which is x squared minus 1. So I need to deal with my order of operations. So I need to square this, which I can think of x squared minus 1 times x squared minus 1. Good thing we just spent some time on multiplying. I can't just distribute the exponents because it's a subtraction. So I'm going to leave my 2 and I'm going to multiply here. So x squared times x squared would be x to the 4th. X squared times negative 1 will be a negative x squared. Negative 1 times x squared will also be a negative x squared. Negative 1 times negative 1 will be a positive 1. So let me combine some like terms here. X to the fourth minus 2x squared plus 1, and then distribute my 2. So I have 2x to the fourth minus 4x squared plus 2. This is my answer to f of g of x. Okay. It gets a little cumbersome, a little tedious, but it doesn't get any harder than this. So for my second problem, I'm going to start with my g function. So that is going to be x squared minus 1. I always like to start with the outside function, whichever one is first. Write it out with the placeholder in for my parenthesis, with my parenthesis for my x value. And then in here, I'm going to plug in my entire f of x function into this entire space, which is 2x squared. So order of operations, I need to square this. I'm going to write this as 2x squared times 2x squared, and then I have a minus 1. So I have to multiply these together first. I don't really need to distribute. I just need to do the multiplying. I have 4x to the fourth, and then a minus 1. So this is my answer to g of f of x. Right? So two functions. I plugged f in, or I plugged a g into f, and I plugged f into g. I got different answers. So the order that we plug them in does make a difference. Right, so for my third problem, I'm going to plug in a function into itself. So start with the outside function, which is 2 and then x squared. In this space, I'm going to plug in my entire function, f of x. I plug it in again. So this time I plug it in with the x, so I have 2x squared. And then I'm going to clean this up with my order of operations. So I'm going to keep my 2. My 2x squared squared, I'm going to write as 2x squared times 2x squared. I'm going to leave my 2, multiply these together. That would be 4x to the fourth. And then distributing, I have 8x to the fourth. And this is f of x. All right, so it's substitution, not using a number, but using a different function. All right. So here I have another example. I'm finding g of y plus 1, and this is my g of x. So in this case, I don't have a different function that I'm using, but this is the value that I plug in, and I plug it in for my x. And since I have two x's in my equation, I'm going to plug it in twice. So g of y plus 1, I'll have 2x squared minus 4x plus 2. I like to start with the outside function and put place markers in for where my x values are. Into these x values, I'm going to plug in my other function, which is y plus 1. All right, so order of operations, you deal with my exponent first. So I could think of this as 2 times y plus 1 times y plus 1, and then minus 4 times the y plus 1, and then a plus 2. So I'm going to multiply these together first. So keeping my 2. I have y squared plus y plus y plus 1. Let me just copy down the rest. Combining like terms, I'm just going to write above this y squared plus 2y plus 1. So I'll have 2y squared plus 4y plus 2, and then distributing here, minus 4y minus 4, and then a plus 2. We need to combine like terms, so I have 2y squared. That's my only y squared term. So if I look at my y to the first, I've got a positive 4y and a negative 4y. That's 0, so I'm just going to leave those alone. Then I have a plus 2, a minus 4, and a plus 2. That's also 0. So this is my final answer, 2y squared, which just happens to be small. Usually it's a lot bigger, but my like terms combined. All right. Any questions so far? Feel free to type them in the chat. My next one is a 3-parter. So here I have a of x, b of x, and c of x. And I want to find b of a of c. So it's not harder, it's just a little bit more complex where I have more things that I have to plug in. So I'm going to start with my outside function, which is a b, which b is 6 minus x. So I have 6 minus x. I'm going to leave a large space because I have another composition to put in this space. Inside this space, I'm going to type in my a function, but not the entire a function, just the outside shell of my a function without the x. So I have x plus 3. And then in this space, inside of my a function, I'm going to plug in my entire c function, which is 3x plus 2. All I need to do now is simplify the entire polynomial. So I have a 6, I have a minus. Now in this parenthesis, I've got some things going on. Nothing's being multiplied by my 3x plus 2, so I can combine my 3x plus 2 with this plus 3. So these like terms will combine, and I'll have 3x plus 5. Instead of subtracting, I'm going to distribute the negative and add the opposite. So I have 6 minus 3x minus 5. And then combining like terms, I will end up with my final answer. Close. Think any other one? Okay. And this is equal to negative 3x plus 1. So just a side note, on your homework, there's some digital homework that we'll be doing, and they ask you for a number. So if I wanted to find b of a of c of, let's say, 7, I follow the same format, but this number here will be 7. So what you can do is you can either simplify it all the way down with an x and then plug in 7. So negative 3 times 7 plus 1. So we have negative 21 plus 1, or negative 20. Or I can do it from my original here. So starting with my b, I'll have 6 minus the x. And then I have in here my x plus 3. And then I have 3 times my x value 7 plus 2. And then I just need to simplify here. So this will be 21 plus 2 and then plus 3. So 21 plus 2 is 23, plus 3 will be 26. And then 6 minus 26 will be a negative 20. So if you have a specific number, your final answer will be a specific number. If you have an x, then my answer will obviously have an x. Okay, compositions of functions. Right, next are my inverse functions. Inverse functions do the opposite. So some inverse operations if I am multiplying, the inverse operation is division. If I am adding, my inverse operation is subtracting. If I am squaring, my inverse operation is square rooting. So inverse functions just takes a function and does the opposite or takes it back. So if my function is to add 4, then the inverse function is to subtract 4. If my function is to multiply by 4, then the inverse function will be to divide by 4. So it does the opposite so you can get back to the original. So notation, if I start with a function of f of x, this is how I write the inverse. So I read this as f inverse of x. So this negative 1 is the word inverse, which is to do the opposite. There are 2 steps to find the inverse. We switch the variables x and y, and then I solve for y. So anytime we have an inverse, so if I had a point on a graph, let's say it was 3, 5, the inverse of this is to literally just switch the x and the y's. So the inverse is the point 5, 3. So we just switch them. No negatives, no multiplying, we just switch them. So I've got some functions here that we're going to find the inverse for. So number 1, I have 3x minus 4. You might notice that there is not a y. So instead of f of x, I'm going to write this as y equals 3x minus 4. So step number 1 is to switch the variables x and y. So I'm going to write this as x is equal to 3y minus 4. The only thing that switched is the letter. The 3 still multiply, there's still a -4, but I literally switched the letters x and y. Now it's like a regular algebra 1 problem where I need to solve for this variable y. So I'm going to add 4 to both sides. So x plus 4 is equal to 3y. Then my coefficient of y needs to be eliminated. So I'm going to divide by 3. I highly recommend that you divide everything by 3. It makes it a little bit easier and you don't miss something. So x over 3, I can write as a 1/3 x. I have 4 over 3, so I believe that is 4 over 3. You are more than welcome to write as a decimal if you want. So this is what y equals. So my inverse function, f inverse of x, is equal to this equation here. 1/3 x plus 4/3. So the way that this works, if I plug in a number, let's say 5, and I do my function here, and then I take that same number and I plug it in here, I'm going to output a 5. So it undoes the work that I did with the inverse function. All right, got a few more examples here to find the inverse. So number 2, I have f of x equals x squared minus 16. So I'm going to write this as y equals x squared minus 16, and then switch my letters. So x is equal to y squared minus 16. Notice that the exponent stayed in its same position, but it went to a different letter. So I'm going to add 16 to both sides. So x plus 16 equals y squared. I need to unsquare this. To unsquare is to square root. So I'm going to square root both sides. So y is equal to the square root of the entire x plus 16. Now I can take the square root of 16, but I can't take the square root of something plus 16. Because if that was 1, it'd be the square root of 17. If it was 2, it'd be the square root of 18. So just leave it. So my answer, f inverse of x, is equal to the square root of all of x plus 16. Make sure your square root continues. All right. Next, I have f of x is equal to 1/2 x plus 12. So I'm going to write this as y equals 1/2 x plus 12. Then I'm going to switch my x and my y. So x is equal to 1/2 y plus 12. So I'm going to subtract 12 from both sides. X minus 12 is equal to 1/2 of y. So my coefficient of y needs to be eliminated. What do I multiply 1/2 by to get 1? Now, it's a fraction, so I can multiply by its reciprocal, which I'm going to write as 2 over 1. So I'm going to put this in parentheses and multiply this by 2. So I have 2x minus 24, got to multiply both items by 2, is equal to y. So my f inverse of x is equal to 2x minus 24. These are not hard. They can be a little bit tedious in solving, so just take your time. There is a way to check, and we'll talk about that tomorrow. All right, and then number 4 down here, f of x is equal to the square root of 2x minus 6. So I'll write this as y is equal to the square root of 2x minus 6. And then switching, x is equal to the square root of 2y minus 6. Then I need to solve for y. Now, y is underneath this large radical, so I cannot move the 6 because it is also underneath the radical, but I can go ahead and square both sides. So x squared equals the square and the square root are inverse operations. So I'm left with 2y minus 6. It just comes out nicely. I'm going to add 6 to both sides. So x squared plus 6 is equal to 2y. And I'm going to divide everything by 2. So I have 1/2 x squared plus 6 divided by 2 is 3 is equal to my y. Fractions I like to write as coefficients times my variable. That's just a personal preference. There's nothing wrong with x squared over 2. But my inverse function is equal to 1/2 x squared plus 3. So just a small notation when I have something squared and I need to square root it, I got to square it the whole side. When I have something square rooted, I'm going to square both sides, right? So don't try to move the 6 before it's been square rooted, and don't try to move the 16 or square root the 16. Just leave it underneath the radical. All right, any questions for the recording? Your assignment is digital today. It is on Delta Math. And so we'll go over how to find it and what to do with it in a moment. Any questions?